In the third tutorial, we configure an analysis to calculate setup times over a production shift in ibaAnalyzer. We show how the duration of the setup processes is determined with the integral function, mark the maximum values with smart logic, and extract relevant time points. The recorded values serve as the basis for a later report, which will be explained in the next tutorial. So let's start with the analysis template. This template is also based on the process data of the hot rolling mill, more precisely on the setup times between the individual orders. We start again by opening suitable measurement data. As we want to evaluate the period of an entire production shift in this case, we use data from an ibaHD server. We open the period of a late shift, from 14 to 22 p.m. We find the necessary process data in HD Store 2. As before, the query returns our signal tree with all available process signals. I would like to point out once again that ibaAnalyzer makes no difference when processing the different signal sources. So let's start with the evaluation. In Module 6, we find a suitable digital signal that identifies the setup process, the signal 6.3. The integral function helps us to determine the duration of the setup processes. Add a new signal by right-clicking and open the function editor. We select the int function, or the signal 6.3, and see that the integral function sums up the runtimes of our setup process. For a better overview, we can also drag the signal into the upper trend. For the subsequent report, we need, among other things, the total runtime. In other words, the maximum value of the previous result. To do this, we generate a new signal. For this calculation, the previous function can simply be supplemented by a max function. If you are familiar with the syntax, the function does not always have to be created via the function editor. It can also be entered directly in the expression field. If we duplicate this signal and divide the result by 60, we also obtain the maximum setup time in minutes. In addition to the total runtime, the individual runtime of each setup process is also required. For a better overview, drag the signal 6.3 into the signal strip again and add another new signal. The integral function provides a reset argument for the calculation. The falling edge of the signal 6.3 can be used for this. To detect this edge, the ftrig function is suitable. The result is a sawtooth pattern. The first step is now complete. However, we now no longer need one maximum value, as with the total runtime, but many single maximum values. The values that mark the maximum value of each sawtooth must therefore be selected from the trend. How can this be realized in a smart way? The position of the required maximum values can be determined precisely, as they always lie above the falling edge of the signal 6.3. The ftrig function can therefore be used again. However, if you zoom in on one of the edge changes afterwards, you will notice that the detection of the falling edge is marked with the next measuring point. So this signal is not suitable for marking the position of the maximum value. It must first be shifted. As the shift is exactly one measuring point, it can simply be calculated using the xbase function. The result shows that the calculation is correct. We can now use the result to mark the maximum values. We use the xMarkValid function for this. We already used a similar function in the previous example. To be able to use the result later, only one step is missing. As we are currently dealing with individual measuring points, but we can only process signal series, we have to close the gaps with the fillGaps function. We have now collected almost all the information for our report. What might still be missing is the time when the respective setup process was completed and the duration of the query period. The first piece of information can be created quickly using an additional signal, as the information on the time is contained in the x-axis positions of my previously created maximum values. To evaluate them, we use the xValues function. For the information on the query period, I recommend using the function editor again. As the information is contained in the queried info fields, the syntax is more complex. Again, the result is in seconds, therefore we convert it into a minute value by division. The analysis template is now complete, and we can finish this part of the tutorial. We will see how the data is placed in the report in the following part.